Hi, my name is Arush Agarwal and my Capstone project is titled Recommendation System. It is a recommendation system for movies, TV shows, and books. First, let's understand what is a recommendation system. A recommendation system is an application of information filtering. It studies the user's interests and preferences and implies some algorithm to find the user's personalized needs and actively and efficiently recommend information and content to the users. In simple words, it offers personalized suggestions for each user. Next, we will explore why is it needed. In the age of digital content consumption, the vast array of movies, shows, and books available can be very overwhelming for the users. Let's be honest, so many times we have sat down with our hot food and started browsing a streaming site like Netflix to look for something to watch. But we were not sure what we were looking for, and during that search, only our food got cold. This is where recommendation systems come into the picture. They provide recommendations when it is tough to even express our needs. It enhances the user experience and engagement by providing personalized suggestions. It also helps in saving the user's time. There are two types of recommendation system. First, content-based filtering. Second, collaborative filtering. Content-based recommendation system recommends items similar to those a user has liked or selected in the past. It focuses on item characteristics. For example, if user A likes book 1 and book 2 is similar to book 1, then book 2 will be recommended to user A. Collaborative filtering recommendation system recommends items based on the preference of users with similar tastes. It focuses on other users' ratings and opinions. For example, user A and user B both like book A1 and book 2. User A likes book 3, then book 3 will be recommended to user B as well. In this project, I have created a content-based recommendation system. Now let's get into the datasets used in this project. I have used three datasets here. First, movies dataset, which contains 700k plus rows and 20 columns, and the size is 350 MB. I have taken movies from 1970 to 2023. Next is TV's dataset, which contain 150k plus rows and 188 columns, and size is 250 MB. Third is books dataset, which has around 10k rows and 8 columns, and size is 11.75 MB. During the data pre-processing, these datasets were cleaned, unnecessary rows and columns were dropped, missing values were filled, and sanity check for numerical variables was done. Now let's look at the EDA. So this is the EDA of movies dataset for number of movies per genre. This shows that this dataset contains movies from all the genres, so there will be no bias and there is ample amount of movie genres for the users to select a movie from. Next, we have number of movies released each year. This dataset contains movies from 1890s to 2023. After looking at this plot, I decided to take the movies from 1970s to 2023, since usually people are not interested in very old movies. Here's the TV shows dataset, EDA, a number of shows per genre. This dataset contains shows from all the genres. Third is books dataset EDA, number of books for top 20 genres. This dataset contains books from all the genres, mostly are fiction books. Now let's discuss about the techniques used. I have used two techniques to create content-based recommendation system. First is count vectorization. This technique converts a collection of text documents into numerical feature vectors. It works by counting the frequency of words in each document and constructing a matrix representing the entire corpus. How this works? First, tokenization. The text data is tokenized into individual words or terms. Then, for each document, a count of the occurrences of each word in the vocabulary is recorded. Then vectorization is done, where each document is represented as a vector where each element corresponds to the count of a specific word in the vocabulary. Then cosine similarity is used where items with similar count vectors are considered more related. Limitation of count vectorization is that it doesn't take into account the importance of words in the document. Next technique is TF-IDF, term frequency inverse document frequency. TF-IDF is a numerical statistic that reflects the importance of words in a document relative to the collection of documents. It is calculated based on two components. First, term frequency, which measures how frequently a word appears in a document. Next is inverse document frequency, IDF, which measures how important a term is across all the documents. TF-IDF score is just a multiplication of TF and IDF values. After this, cosine similarity is used, and the system recommends items with high similarity scores to the users based on their selected movie. TF-IDF takes into account not only the frequency of terms in a document but also how unique these terms are across the entire corpus. Here is an example of the results I got from both the techniques when I selected Batman movie. As we can see, all the results of TF-IDF are related to Batman, but that is not the case with the count vectorization results. For example, Dick Darcy is a movie about a detective and the gangsters. So, after comparing the results, TF-IDF was selected as main model for this project. Potential applications. The developed recommendation system has the potential to enhance user experiences on platforms offering movies, shows, and books. It can be integrated into streaming services, online bookstores, and media platforms to provide personalized content suggestions tailored to individual tastes. Lessons learned. Throughout the project, valuable lessons were learned about the challenges in natural language processing, including the nuances of text representation and the importance of understanding user context. The importance of data quality became evident, ensuring completeness and lack of bias in the dataset is fundamental for accurate recommendations. The iterative nature of system development taught the value of continuous refinement and adaptation to changing requirements. Recognizing the dynamic nature of user preferences highlighted the necessity for flexible algorithms. Limitations. Despite the progress made, there are limitations to this work. The system relies heavily on the quality and quantity of textual data available. Incomplete or biased datasets may affect the accuracy of recommendations. Additionally, the system does not consider user interactions or feedback, which could further enhance recommendation accuracy. No evaluation matrix is used, the results are evaluated manually. Future research scope. As a future step, conducting in depth research on advanced evaluation techniques could provide deeper insights into the system's performance. Deploying user surveys and feedback forms will enable us to gather direct opinions from users, shaping our understanding of their experiences and preferences. Exploring quantitative metrics such as click through rate, CTR, would offer a data driven perspective on users' engagement. It is important to keep an eye on emerging research in the field as new methods for evaluating recommendation systems are continually being developed. Leveraging a combination of qualitative and quantitative approaches will help in creating a more comprehensive evaluation strategy for the future. I have used Streamlit to create an interactive web app for this recommendation system. Here are a few snippets of this app. So this is the home page. This is the movie recommendation page. This is the book recommendation page. Now let's take a look at the web app application. So this is the home page where we have three options of movies, TV shows and books. Let's select movies. Here, let's select Iron Man. Show recommendations. Clicking this button will show 5 recommendations. If the user wants more recommendation, then we can click show more recommendations. These are the recommendations. If the user still wants more recommendation, they can again click this button. Overall, this page can show around 20 recommendations to the user. If we want to select new movie, we can just click on the button, select a new movie. Now let's see for TV shows. This is the TV show recommendation page. Let's select the movie Star Wars and show recommendations. Here are the recommendations for a Star Wars movie. We can see more recommendations as well. Now let's go to the books. This is the books recommendation page. Let's select Harry Potter book here. Show recommendations. Here are the Harry Potter recommendations. We can see more recommendations as well. So here, as we can see, there are 20 books recommendations. We can even select a new book from here. That's it for the project. Thank you.